So in this video, let's look at the third method for cross-validation, which is k-fold cross-validation. K-fold cross-validation, right? Cool. K-fold cross-validation. So this is going to be an alternative to our leave one out cross-validation, right? Because this one had a disadvantage in it, because this was computationally expensive. If you remember, we had to do it n times. We had to feed the model n times. This was computationally expensive. So now, what happens in k-fold is we have our data set just like we did previously. So let's draw our data set right there. 1, 2, 3, all the way up to n. So what is going to happen is we are going to randomly divide the set of observations into k groups. So let's just say we want to divide this into 5 groups. So we're going to have group number 1, isn't it? We're going to have group number 1 there, and then we divide, we will say this is going to be group number 2, and then we are going to have group number 3, right? And then we are going to have group number 4, and then I don't have another color, so I'm just going to do this. So let this be group number 5. So we've divided this into k equal to 5 groups. Usually they are of almost similar sizes, right? And then we're going to take the first fold. This first okay, they are called folds as well. So you can call them groups or folds. Right? So here we have 5 folds, and we're going to take this first fold. And this is going to be treated as the validation set. And the method is fit on the remaining k-1 folds. So which means these folds here, this k-1, they are going to be our training. They are going to form our training set, right? So we're going to fit them. We're going to fit on this, on k-1 folds, because the first one, this number 1 here, has been put as the validation set. So let's write the steps that are going to occur here. Step 1, here we're going to put our validation. Our training set, and then here we're going to have our MSE or our error. Let's write our error. So our error depends, again, it depends. Are we doing classification? Are we doing regression? Regression is just easier. So we talk about MSE. It's just easier to give as an example. So step number 1, our validation set is going to be fold 1. So k equal to 1, right? And our training set is going to be composed of k equal to 2 plus k equal to 3 plus k equal to 4 plus k equal to 5. So those 4 folds, 1, 2, 3, 4, where they started k equal to 2, 3, 4, 5, those are going to be our training set. And after we've trained our model, we're going to fit it on the observations. We're going to fit it on the observations that are inside k equal to 1, our fold 1. So inside our fold 1, we have our, let's say according to our diagram here, we have our x1, y1, x2, y2, and we have our x3, y3. That's what we have in our k equal to 1, right? So we are going to use our model to predict for each one of these. So here we're going to predict y1 for the first observation. We're going to predict y2 for the second observation. We're going to predict y3 for the third observation. And we're going to calculate the MSEs here. What is the MSE here? We're going to have an MSE. And here we're going to have another MSE, and here we're going to have another MSE. Just like we did in when you're doing regression, when you had our training set, our training data. When you have our training data, we're going to have MSEs for each observation, and then we're going to have an overall MSE. You can use the average here. So the average of these MSEs that are in K1 is going to give us our MSE1, and we are going to call that our MSE1. The 1 here does not mean observation number 1. It means our MSE from the whole fold number 1, the whole of fold number 1. We have averaged the individual MSEs for each observation in k equal to 1, and we created our overall MSE for that whole fold. We do the same for step number 2. Step number 2, we are going to, in the validation set, we are going to make k equal to 2, the validation set, and then the other folds are going to be in the training set. So k equal to 1 plus k equal to 3 plus k equal to 4 plus k equal to 5. Those other folds are going to make up our training set. We train it on this, and we calculate our individual MSEs for the observations that are in k equal to 2, and we have the overall MSE for the observations that are in the k equal to 2, and we come up with MSE equal to 2. Same thing happens for step 3. We repeat the process with k equal to 3, and here our training set will be now k equal to 1 plus k equal to 2 plus k equal to 4 plus k equal to 5. And we come up with our MS3. We keep going until our step, in this case we have 5 folds. So it's going to be k equal to 5, and then the same as with the validations, and then here we come up with a MS5. So our validations are just going to be k equal to 1 plus k equal to 2 plus k equal to 3 plus k equal to 4. And then we come up with the overall MSE5. So 5, I'm just putting 5 here. We are going to explain later, but usually we use k equal to 5 or k equal to 10. Those are the main ones that we use. So cool. Now we have our MSCs, right? How are we going to calculate our the estimate for our test error? So the estimate for our test error is calculated like this. We are going to use the k-fold CV error. It is given by, in our case here, we are using MSE, so it's going to be given by 1 over k summation of I equal to 1 up to k of MSEI. So this is how we calculate our k-fold cross-validation error, and this is going to act as our test error estimate. This is our test error estimate. How do we get this? How do we explain this? We are basically just summing up these MSEs that we got, the overall MSEs from each fold, and then dividing them by how many MSEs we had. In our case, we had 5 MSEs. Right? MSEs, yeah. With 5 MSEs, so our k was equal to 5. So it's basically just the mean MSE, mean overall MSE. These ones are overall of each fold, and then we calculate the mean of all of them. We sum them up and then divide them by k. Our k was 5. So that's basically our estimate for the test error using k-fold. And some people have already picked this up. Our LOCV, it is a special case of k-fold. It's a special case because instead of dividing into 5 like this, it means when we're doing LOCV, we've divided our training set or our data set into k equal to n. We've divided by k equal to n. It means each observation is its own fold. That is what LOCV does, right? It divides this data set into individual observations and does those k equal to n steps, and then so LOCV is a special case of k-fold CV, right? Usually when we are doing k-fold CV, we take k equal to 5 and k equal to 10, because it can be shown that the variability is much easier to control, or it's much easier when it's much easier when we use these k equal to 5 or k equal to 10. And also the variability in test error estimates here, it is much lower than validation set approach. I think we agree. The variability imagine that validation so let's look at our variability scale. Let's look at our variability scale at the lower end here. So yeah, let's just say very variable variability, right? Low variability. At the lower end here, we're going to have the validation set approach, because this validation set approach, it trains our data on let's say 500 observations. It trains our data on 500 observations, and that sucks because it might introduce high levels of bias. It might introduce high bias, so it's going to be very variable, right? And then we said on this scale is going to be our LOOCV, low variability, because this one here, it trains our data on, let's say, 999. If we're doing n equal to 1000, it trains on 999, so the bias is going to be very, very low for this one here. But for our k-fold, we're going to have k equal to 5 and k equal to, let's just say k equal to 10. When we're doing k equal to 5, it means we're training our data on, because each fold we have 200. So when you're validating with 200, it means we're training on 800, right? Makes sense. We're training on 800. So we're going to have a training set of equal to 800. So we can have our k equal to 5 here. K equal to 5 CV, right? K equal to 5 CV. When we're doing k equal to 10, it means our training, our validation, we have 100 observations. We have 100 observations, that's in the validation. So it means in our training, we have 900 observations. So which means our k equal to 10 CV will be somewhere there, because we have more observations that we're training on. Less bias, which will lead to lesser variability compared to k equal to 5. So that is the variability scale that we have there. In the next video, we are going to quickly discuss, we're going to take this forward, the last part of cross validation, and then we're going to discuss things like how do you do that in a classification example. When we have a classification example, here we're using regression because it's easier to explain using regression. But what about what happens in a classification setting? So we're just going to finish off cross validation and discuss that last part.